welcome to my YouTube channel BS and MSc Physics channel. This is my third lecture. Today I will solve some questions on Fourier series. So let's start the problem first. Find the Fourier series of the function f of x is equal to x where x greater than 0 and less than 2 pi. We have a function f of x is equal to x, and we will find the Fourier series of this function and this limit. Okay, so we will require to find a naught, a n, b n, and f of x, then last Fourier series. Okay, solution. As we know that Fourier series formula is f of x is equal to a naught divided by 2 summation n star from 1 up to infinity a n cos nx plus summation n star from 1 up to infinity b n sin nx. This is my equation A. And we also know that we have a naught is a coefficient of Fourier series, and we have also the numerical value of a naught. So this is the formula for a naught. A naught is equal to 1 over phi integral 0 to 2 phi f of x into dx. So f of x, we have given that f of x is equal to x. So we will put the value of f of x. A naught is equal to 1 over phi integral 0 to 2 phi. We will put the value of f of x is here, x into dx. So is equal to 1 over phi. We will integrate x. So the integration of x is x squared divided by 2, and limit is 0 to 2 phi. So now a naught is equal to 1 over this 2 is multiplied to phi, so 1 over 2 phi x square, limit 0 to 2 phi, 1 over 2 is equal to 1 over 2 phi. Now we will apply the limits. So first we will put 2 phi and x, so 2 phi whole square minus then 0, put the limit of, so minus 0 is equal to 1 over 2 phi. 2 pi square is equal to 4 pi square, so 2 pi is cancelled with 4 pi, so 4 pi square, so a naught is equal to 2 pi. This is my equation 1. This is a naught. We find a naught. Now we will find a n. So we have also given a formula for a n. A n is equal to 1 over phi integral 0 to 2 phi f of x cos nx into dx. So a n is equal to 1 over phi, and we have the value of f of x. F of x is a function, and this f of x is a function, so the value of f of x is x. So we will put x and cos nx into dx. So now this is two function. X1 is one function, our cos nx is the second function. So now we will solve this integral by integration by parts formula. So we know that the integration by parts formula is f of integral f1 of x f2 of x into dx is equal to this f1 f2 is this is one function, this is second function. So we will integrate these two functions, and by integration by parts formula is f1 of x integral of second minus derivative of first function integral of second function. Okay, so this is the integration by parts formula. So we will solve the n by integration by parts formula. So here where x is my first function and cos nx my second function. So 1 over phi whole bracket first function is x, so x integral 0 to 2 phi cos nx minus whole integral 0 to 2 phi derivative of first function, so derivative of x integral of cos nx into dx. This is my second function. Okay? Now a n is equal to 1 over phi So the integration of cos nx is sin nx divided by n. X is multiplied with the sin nx divided by n. Limit 0 to 2 pi minus this 1 over pi is also with the this function, this, so multiply by, here is 1, so 1 multiplied by 1 over pi, so 1 minus 1 over pi, integral derivative of x with respect to x is 1, integration of cos nx is sin nx divided by into dx. Now multiply this pi with n, so 1 pi x sin nx limit 0 to 2 pi minus this pi is multiplied with n, so minus 1 minus, now integrate this sin nx with respect to x, so the integration of sin nx is minus cos nx and divided by n. So apply the limits, so n is equal to 1 over n pi. Now we will apply the limit, so we will put the limit with nx, so we will put 2 pi sin 2n pi minus, here we will put the limit 0 here and here, so 0 sin 0, this minus will multiply with this minus, so this will be positive, and this n is multiplied with this n pi, so we will get 1 over n square pi, and we will apply the limit here, so cos 2n pi minus cos 0. Now we know that sin 2n pi is equal to 0, sin 0 is equal to 0, cos 2n pi is equal to 1, and cos 0 is also equal to 1. So n is equal to 1 over n pi, 2 pi sin 2n pi is equal to 0, so we will put 0, and sin 0 is also 0, plus 1 over n square pi, cos 2n is equal to 1, so 1 minus 1, cos 0 is also 1. So now n is equal to 1 over n pi, 0 minus 0 plus 1 over n square pi, this 1 minus 1 is also equal to 0, so 0 plus 0, n is equal to 0. This is my second equation T. Now we will find the third coefficient bn. So bn is equal to 1 over pi integral 0 to 2 pi f of x sin nx into dx. So we know that f of x is equal to x, so we will put here x in place of f of x sin nx into dx. So now we will say this is my first function, this is my second function. We will solve this integration by parts formula. So bn is equal to 1 over pi, this is my first function, this is my second function. First function integral of second function minus whole integral derivative of first function integral of second function. bn is equal to 1 over pi, here x integration of sin nx is equal to cos nx divided by n. Integration of sin nx is minus cos nx divided by n. So this minus is for before minus, this minus is placed before x. So integration of sin nx is a minus cos nx divided by n. Okay, whole limit 0 to 2 pi minus whole integral derivative of x with respect to x is 1, and integration of sin nx is a minus cos nx divided by n. Now bn is equal to minus, this minus is put before the bracket, so minus 1 over n pi, this n is multiplied with pi, and this is x and 2 cos x, so cos nx, limit 0 to 2 pi, plus this minus will multiply with this minus, so we will get plus 1 over n pi integral 0 to 2 pi cos nx into dx. Bn is equal to minus 1 over n pi cos x cos nx limit 0 to 2 pi plus 1 over n pi integration of cos nx. This integral gives us integration of cos nx is sin nx divided by n limit 0 to 2 pi. Apply the limits. Bn is equal to 1 over minus 1 minus 1 divided by n pi. Now we put the limit nx, so 2 pi cos n 2 pi minus 0 cos 0 plus 1 over n square. This n will multiply with the n pi, 1 over n square pi. Limit f, we will apply the limits, so sin 2 n pi minus sin 0. So Bn is equal to minus 1 over n pi cos 2n pi is equal to 1 and cos 0 is equal to is also 1, but here is 0, so we will multiply with the cos 0, so 0, so this gave us 0. Now sin 2n pi is also 0 and sin 0 is also 0. Okay, so Bn is equal to minus 1 over n pi, this is 2 pi and this gives us 0, so pi is cancelled with pi, so minus 2 by n. Bn is equal to minus 2 by n. This is my equation 3. Now we will put equation 1, equation 2, equation 3 and equation a. We will get f of x is equal to, put the value of a naught, bn and an. So we will get equation a implies that f of x is equal to 2 pi by divided by 2 plus 0 plus summation n star power 1 up to infinity minus 2 divided by n sin nx. F of x is equal to, this will give us pi and this is summation n star power up to infinity minus 2 divided by n sin nx. This is also answer. This is answer, required answer. Or we will write this f of x is equal to pi minus this 2 is written before the summation, so and we will expand the summation. Sin x n start from 1, so we will put n is equal to 1, so we will give sin x divided by 1. Here is n. Now we will put 2, so sin 2x divided by 2. Now we put 3, sin 3x divided by 3. Here n start from 1 up to infinity plus up to infinity. This is also required answer. Okay, now we will this is the required answer of the, this is the required Fourier series of the function f of x is equal to x within the limit 0 to 2 pi. Okay, now we will solve another problem. Find the Fourier series of the function f of x for 3 values given by f of x is equal to minus 1 for minus x is greater than minus pi and less than minus pi by 2. F of x is equal to 0 for minus pi by 2, x is greater than minus pi by 2 and less than pi by 2. F of x is equal to 1 for x is greater than pi by 2 and less than pi. So this is the limit for these 3 functions. Okay, so we will find the Fourier series of the given function for 3 values given before. So we will find the required is a naught, a n, b n, f of x. Solution is, as we know that Fourier series is f of x is equal to a naught divided by 2 plus summation n star from 1 up to infinity a n cos nx plus summation n start from 1 up to infinity b n sin nx. This is my equation a. Now first we will find a naught, as we know that a naught is equal to 1 over pi integral limit minus pi to pi into dx. Why we take the limit minus pi to pi in this problem? So we know that in question, so the limit start from minus pi to pi. So there are three functions and their limit are different. So we will the total period of this function is mean 2 pi. You will see this from minus pi to pi, minus pi by 2, 0, pi by 2 and pi. So from minus pi, this is minus pi and this is pi. So pi minus pi is equal to 2 pi. The period is 2 pi also. So now we know that a naught is equal to 1 over pi f of x is equal to minus 1 is and the limit is minus pi by 2 is minus 1 into dx plus 1 over pi integral integral minus pi by 2 to pi by 2. The function is 0 plus 1 over 2 integral from pi by 2 to pi. The function is 1. Okay, so a naught is equal to minus 1 over pi into, we will integrate this minus 1. So minus 1 is constant, so we will take out from the integral. So the integration of this is x, my limit is minus pi to minus pi by 2 plus the integration of this constant is 0 plus integration of this function is this is constant 1 over pi and the integration of this integral is x, limit is pi by 2 to pi. Now we will apply the limits. This minus 1 over pi is, this is minus 1 over pi, so we will put limit here. So minus pi by 2 minus pi and minus pi multiplied by minus, so plus pi. This is 0 plus 1 over pi, we will put limit here. So pi minus pi by 2. Okay, now a naught is equal to minus 1 over pi, so take the LCM of these two. So LCM is 2 here, so minus pi plus 2 pi plus 1 over pi. Here we will take LCM, so 2 pi minus 2 divided by 2. Here we know that as cosine is even and sine is odd, so cos minus x is equal to cos x and sine minus x is equal to minus sine x. Okay, remember this part. Okay, cos is even and sine is odd, and we will show in the graph also later. Okay, that cos is even and sine is odd. Now a naught is equal to minus 1 over pi, so 2 pi minus pi by 2 plus 1 over pi 2 pi minus pi by 2. So this is minus and this is plus, so there these two are cancelled each other, so a naught is equal to 0. This is my equation 1. Okay, now we will find a n. A n is equal to 1 over pi integral minus pi to pi f of x cos nx into dx. Here we have three values of f of x. F of x is equal to minus 1, f of x is equal to 0 and f of x is equal to minus 1, and the limit is also changed for every function. For minus f of x is equal to minus 1, limit is minus pi to minus pi by 2. The limit for f of x is equal to 0 is minus pi by 2 to pi by 2, and the limit for f of x is equal to 1 is pi by 2 to pi. So we will see this n is equal to, this is the general formula for n, so 1 over pi integral minus pi by minus pi to minus pi by 2. The function is here minus 1, and this is cos x into dx. Now plus 1 over pi. For function f of x is equal to 0, the limit is minus pi by 2 pi by 2 cos nx into dx plus 1 over pi. The limit for f of x is equal to 1 for function 1 f of x is equal to 1 is pi by 2 to pi into cos nx into dx. Here n is equal to minus 1 over pi. The integration of cos nx is a sin nx divided by n, and limit minus pi to minus pi by 2. Integration of this, so this is 0 multiplied by cos nx, so this will give 0. Integration of 0 is 0 plus 1 over pi. Integration of cos nx is sin nx divided by n, and limit is a pi by 2 to pi. Okay, now n is equal to minus 1 over minus 1 divided by n pi. We will apply the limit. So sin n we will put the limit in x, so this is sin n, and we will apply the limit here in x, so minus pi by 2 minus sin n minus pi plus 1 over pi, 1 over n pi. This n is multiplied by with pi, so 1 over n pi. Apply the limit sin n pi minus sin n pi by 2. So n is equal to minus 1 divided by n pi. I already told you that sine is an odd function, so this minus will take out before sine, so minus sine n pi plus sine n pi divided by 2 plus sine, and this minus and this minus will give us positive, so sine n pi plus 1 over n pi sine n pi minus sine. Take 1 over n, here n 1 over n pi, and here is 1 over n pi, so we will take whole common is 1 over n pi integral. This is first I will write um, this sign, this minus and minus, but this minus multiplied by minus plus, and this minus multiplied by minus, so we will take 1 over n pi, so here we will get sin n pi divided by 2, here minus sin n pi sin n pi plus sin n pi, this minus sin n pi this. If we multiply this, if we multiply this with this, so minus 1 over n pi multiplied by minus sin n pi, so we will get plus sin n pi divided by 2 into n pi. If we multiply this with this, so we will get minus sin n pi divided by n pi, so we will get this. Now you will see this is positive, this is minus negative, so they cancel each other, and this is negative and this is positive, so they will cancel each other. So n is equal to 1 over n pi, this will give us 0 minus 0, n is equal to 0. This is my second equation. N is also equal to 0. Now we will find the last term bn, so we will put n in equation f. bn is equal to, as we know that bn is equal to 1 over pi integral minus pi to pi f of x into sin nx dx. bn is equal to 1 over pi integral minus pi to minus pi by 2 minus function is minus 1 sin nx into dx plus 1 over pi our function f of x is equal to 0, limit is minus pi by 2 to pi plus 1 over pi integral pi by 2 to pi function is f of x is equal to 1 sin nx into dx. Bn is equal to minus 1 over, this minus will take out from integral, so minus 1 over pi, and the integration of sin nx is cos nx divided by n, and limit is minus pi to minus pi by 2. This multiply with this, so give us 0. The integration of 0 is equal to 0, plus 1 over pi. Integration of sin nx into dx is minus cos nx divided by n, limit pi by 2 to pi. Bn is equal to, this n is multiplied with pi, so 1 over n pi, and we will apply the limit. So this minus multiply by minus is give us positive. Okay. So cos n, we will put n limit and x, so minus pi by 2 cos n into minus pi by 2 minus cos n, we will put an x minus pi, so cos n minus pi, plus 1 over pi. So this is plus and this is minus, minus into plus we will get minus, so 1 over n pi multiply n multiply by pi is n pi. We'll apply the limits, so cos n pi minus cos n pi by 2. Bn is equal to 1 over n pi, cos, I already told you that cosine function is even, so this give us positive. So this gives us positive, cos n pi divided by 2 minus cos n pi, this minus, this is minus, so minus, and this minus will absorb this cos, because cos cosine is a even function. I already told you. So cos n pi 1 over n pi cos n pi plus minus cos n divided by 2. Taking 1 over n pi is common, so bn is equal to 1 over n pi is common. This is cos n pi divided by 2 minus cos n pi, so this minus multiply, so we will get minus cos n pi plus this minus multiply by minus, so cos n pi divided by 2. Bn is equal to 1 over n pi, the cos n pi divided by 2, cos n pi divided by 2 is 2 cos n pi by 2 minus this minus and minus will add up, so minus 2 cos n pi. Taking 2 is common, so bn is equal to 2 divided by n pi cos n pi divided by 2 minus cos n pi. This is equation 3. Now we will find the Fourier series function. So putting values in equation a from 1, 2 and 3, we get equation a implies that f of x is equal to a naught is 0 divided by 2, a naught value is 0, so we'll put the value up from 1, 2 and 3, so 0 divided by 2 plus summation and start from 1 and infinity is 0 and 2 multiply by cos nx plus summation start from 1 up to infinity. Bn value is this, so 2 divided by n pi cos n pi divided by 2 minus cos n pi n2 sin nx. This is 0 and this is also 0. Summation plus summation and start from 1 up to infinity. 2 divided by n pi n2 cos n pi divided by 2 minus cos n pi n2 sin nx. Expand the summation. Now we will expand the summation. This is also the answer, but we will further to modify the answer, so we will get and so expand this summation, we will get f of x is equal to this 2 by pi is take out from the bracket, and this cos nx n pi divided by 2. Here you will see that this is 1 over, here 1 over n cos n pi divided by 2 minus cos n pi and sin nx into sin nx. So we will expand this series, this summation, and if n is equal to 1, so this is 1 over 1. Here 2 divided by pi is also take out from the brackets. So here we will put 1 over n cos, put n is equal to 1, so cos pi by 2 minus cos pi into sin x. Now we will put n is equal to 2, so we will put n is equal to 2. So here 1 over n, so put n is equal to 2, and 2 by 5 is also common. So 1 over 2 cos 2 pi divided by 2 minus cos 2 pi into sin 2x up to infinity. So 2 divided by pi, this give us cos pi by 2. We know that this is 0, and minus cos pi is minus 1, so minus multiplied by minus give plus. Later sin x plus 1 over 2 cos 2 pi divided by, so this 2 is cancelled with this 2, so cos pi is equal to minus 1, and minus cos 2 pi is also minus 1 into sin 2x plus up to infinity. F of x is equal to 2 divided by pi, this minus multiplied by minus plus, into sin nx plus 1 over 2 minus 1, so gives minus 2 sin 2x plus up to infinity. F of x is equal to 2 divided by pi, gives sin x minus this 2 is cancelled with 2, so give us sin 2x plus up to infinity. So this is the required Fourier series of the function given in the problem. So I hope you will learn from me something, and we will meet in lecture 4 the Fourier series. I will also saw some questions on this Fourier series further. Okay, so let's subscribe my channel and share my video with your friends. Thank you for coming. Thank you for this video, and let's wait for the lecture 4. Allah Hafiz.